Hey everyone, welcome to Cassandra Lunch number 86. I will be the guest speaker today. Today's topic is going to be on DataStax Astra's Terraform Provider. My name is Arvind Patel. I'm an engineer here at Anant. Our co-organizers for this event are Rahul, myself, and Josh. We are looking for guest speakers or sponsors. For guest speakers, you can come give a talk. For sponsors, you can get sponsored on our deck if you are interested on being a guest speaker or recommending a guest speaker or becoming a sponsor. You can reach out to myself or Josh. We are part of Data Community DC. Data Community DC is built on being an inclusive environment. So no matter your race, gender, sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is built up of a bunch of different organizations. We're a part of Data Wranglers DC. Our sister lunch, Data Engineers Lunch, is also a part of Data Community DC. If you are interested in more events put on by the various organizations that build up Data Community DC, you can find out more at datacommunitydc.org and their events. So what do we cover here? We cover everything that has to do with Cassandra, talks Cassandra, whether that be open source Cassandra, enterprise versions like DataStax, or variants including Scala or key spaces, Cosmos DB, so anything that is and talks Cassandra, as well as the surrounding ecosystem of tools and software that play well with Cassandra. So for example, what we do here at Anant, Cassandra, Spark, and Kafka, but then also we'll cover things like Airflow in Cassandra, or like today, Terraform in Cassandra, but in the form of DataStax Astra. So this is kind of a point where if anyone's new, they can drop a hi message in the chat, or if you're on YouTube, you can drop it in the live chat. We can see those messages as well. Group rules: if you have a question, ask it. This is meant to be a community. Obviously, be polite and courteous to others. But again, because this is community, we would love to have everyone's input, but please do respect the speaker's preferences, and they'll give their preferences at the time we hand over to them. What we are not, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. DataStax is a partner and a sponsor. GW University also is a sponsor, especially for in-person events. They provide venue space. We also have some program institutional sponsors. Anyone have any jobs, meetup, hackathons, any announcements, they can drop them in the chat. But we do have some events happening now and a little in the future for the community of Cassandra in general. So starting in a couple weeks, just make sure I have my math right, is DataStax Astra's DB Build-a-thon. You can visit them. I can drop this link in the chat real quick. Oh, let me go back here. Just copy this, drop it in the chat. I'll also drop it in the YouTube chat if I can. There we go. And you can follow this link to learn more about the build-a-thon that DataStax Astra is putting on. But it's going to be lasting from February 21st to May 28th. It's going to occur of 3 months with a round encompassing each month. And the top 3 winners of each round qualify to present their project ideas on demo day, which will be on the 28th. So depending on your schedule, you can either attend the first month of challenges, the second month of challenges, or all 3 months of challenges. So whatever works best for you and your friends, or you and your coworkers, whoever you're working with at the time. And so there's monthly challenge prizes, and then there's also the grand finale demo day, as mentioned, the top 3 winners from each round of challenges. But then there's also awards like the engagement awards, learning pathways, and swag that other people can win. So you can check out that link. It's in the Zoom chat as well as the YouTube chat. Also currently ongoing, yesterday was the first day, but today is the second day of the Scala Summit. The event I think ends today at 6 p.m. Eastern. So if you were not able to attend yesterday, feel free to check it out, but obviously after Cassandra Lunch, right? But yeah, Skilla Summit is ongoing, and you can check it out by just going to or Googling Skilla Summit and attending. So Anant is hiring some of our own promotions. We are hiring full-time or part-time positions, whether that be a data platform operator, engineer, or an architect. You can find out more at careers.anant.us. Obviously, this is currently happening, but this is just a reminder that we have that Cassandra Lunch is happening now on Thursdays, currently at 12 p.m. Eastern, but we are looking into having a more variable time slot so that way more people around the world can attend live. But again, these are live streamed directly to YouTube. So if you do miss it live, you can always catch it on our YouTube channel, youtube.com/AnantCorp. Be sure to subscribe, and you can also find it by Googling the Cassandra Lunch playlist on YouTube as well. So some upcoming events that we have by us here, our sister lunch, Data Engineers Lunch. On Mondays at noon Eastern, we have a guest speaker from Transform. They'll be giving a talk on Monday. And then we also have upcoming Cassandra lunches for the rest of the month. And again, as mentioned, you can find all of these videos on YouTube, youtube.com/AnantCorp, and you can find them on the Cassandra Lunch playlist. Cassandra.Link should be your number one resource for all things Cassandra, as well as the ecosystem. So Cassandra.Link is hand curated by the team here at Anant for the best resources that are about Cassandra or anything in the surrounding ecosystem. As you can see in our tags, we have Cassandra, Spark, Kafka, but everything ranging from anything that is or talks Cassandra. And with that, we will go ahead and move on to today's topic, which will be DataStax Astra's Terraform Provider. And just going over my preferences, I don't have any in terms of if you have any questions, feel free to drop them in the chat, or feel free to speak up, interrupt me. But if you feel more comfortable by waiting to a more proper waiting point, like when we switch over from the deck to the demo, feel free to do that as well. But as mentioned, it didn't properly go to the slideshow, but okay. So today's topic is going to be on DataStax Astra's Terraform Provider, and we'll discuss how it can be used to manage the Astra infrastructure. Terraform, if you're not familiar with it, it's an open source infrastructure code software tool, which allows like consistent CLI workflow for managing hundreds of cloud services. It cloudifies like cloud APIs so that everything you do and manage can be done in a declarative configuration file. And with that file, you can manage essentially your full life cycle. You can create new resources, manage existing ones, or destroy ones that you're no longer needed. So like an example of that declarative files to the right here, where we have like a resource, which is an AWS instance, and then we have like the local name attached to it. And so we define the AMA type, instance type, availability zone. And so here, if this is the first time you're running it, if you do like your Terraform apply, we'll get to that once we get to the demo portion. But if this doesn't exist, when Terraform picks it up, it can create that new resource, and then it'll track it in state. You can also have variables, tags, descriptions, a ton of cool stuff that you can manage all your infrastructure across multiple clouds if needed. And so the configurative files are written in HashiCorp configuration language, HCL, which allows, again, the concise descriptions of resources using blocks, arguments, or expressions. They have some methods that you can use. Say if you get like a list of your databases, you need to access, and we'll take a look at that in the demo portion, but you need to access certain IDs of your list of databases. You can do that using HCL and the methods available in HCL. So with Terraform, you can manage low-level components as well. So like compute, storage, networking, as well as high-level components like DNS entries or SaaS features. So it's a very versatile tool that's very popular in all people's DevOps CLI or DevOps CI/CD pipelines. And it also, as mentioned, keeps track of your infrastructure in a state file, and we'll take a look at that once we get to the demo portion. And this state file is used to determine changes to your infrastructure, so that way it's tracked appropriately and does it as concise with the configuration. And some of the other features that they have, Terraform Plan, which we'll take a look at. It's essentially a way for you to check what your execution plan will be and show you what's going to be changing before you actually do like a Terraform apply. And then you have installable modules where you can download and install community or partner modules from the registry. And some of the cool things when I was learning Terraform is that the dependency graphing, where you can generate what your dependencies look like in your Terraform file, and you can get it in like an SVG format, and we'll show you how to do that today. And then Terraform also has a CDK for experimental features if you prefer to create them, and compatible languages like TypeScript, Python, Java, C#, Go. And again, they have a registry with over 1,000 plus providers. And like today, we'll be using the Astra provider, and that's maintained and developed by DataStax themselves. And it's available on the Terraform registry, and we'll take a look at it. But you can also find the source code available online on DataStax GitHub. But kind of the workflow that happens here, right? So as we write our infrastructure as code in the Terraform file, we do a Terraform plan to see what our plan will be in doing this infrastructure. And then when we do our Terraform apply, that's actually going to apply those changes we looked at. You can skip the plan, but obviously, why would you? Why would you test something without seeing what it potentially could look like? Say if you accidentally remove something from your Terraform file. And so when Terraform picks that up, it's going to be like, oh, we're destroying this from the state. So it'll say, oh, okay, say you have like an AWS instance or AMI that says that you remove it from your Terraform file, and then without doing a Terraform plan, you do a Terraform apply. It'll say, well, it'll have a confirmation as well, so you can see it then. But it's good practice just to do a Terraform plan before you actually do any apply commands. And as mentioned, you can use Terraform to manage across a bunch of different clouds or cloud APIs in general. So take a look at the Terraform registry and take a look at all the different things you can manage with Terraform. And so a little bit more on the Astra Terraform provider itself. It allows DataStax Astra users to manage their full database lifecycle with Astra serverless databases. And so under their resources, you can do access list, a single database pending the ID that you give it, or you can get back a list of databases via the data sources. You can create key spaces, private links, endpoints, roles, and tokens. But then with the data sources, you can also get back data related to the access list, regions, your current or a single database or a list of databases, a single key space or a list of key spaces, and the similar things related to private links and roles. And then you can also get back Secure Connect bundle URLs, which is pretty cool. But to use this Terraform provider, you will require a token, which we did generate ahead of time, but that's just one of the requirements needed when you're running the when you're using the Astra Terraform provider. One thing that they do note is that Astra streaming is not currently supported via Terraform. So currently you can only really do database operations. And so here we have a couple links with the provider on the registry site for Terraform, and then the actual source code for it itself. And then they have a couple of examples, which we'll take a look at in a second. So getting to the demo portion, I'll pause here if there's any questions in the Zoom chat, as well as the YouTube chat. So there's a question in the Zoom chat. Does plan actually test the compatibility? Could you clarify what you mean by compatibility?
Yeah, like does it test that everything's actually going to run? Is it and like connect and without error? I guess is what I was curious about. Like, is it?
I believe
does it ensure that when you apply the plan, it's actually going to work and everything's going to connect together?
I believe it's mainly for just seeing what the configuration changes will be. I don't know if it ahead of time does the actual testing of the like compatibilities between Well, no, you'll, yeah, sorry. It will throw errors if you do have errors. So say if you like did something wrong in your Terraform file, when you do a Terraform plan, based on the provider, right? So like, for example, in our demo, we'll create a new key space, right? And so while I was testing some methods to say, hey, from this list of databases that exist, and we'll take a look at it when we get to the code portion, take the second the second database from the list and extract the ID from that, and then use that as the ID when you create the new key space. And so when I was running that, if I did a Terraform plan, it would fail. But there is a comment from Rahul in the YouTube chat. Connectivity is tested in init. So one thing I didn't mention, but we'll do it once we get to the demo portion, is that once you have set up like your Terraform file and you're getting ready to start working with it, you do a Terraform init, which also does like which also pulls the provider in. And then there's also a follow-up here in the YouTube chat. Plan does a refresh of the state based on what is managed in your code, then a diff. And we'll take a look at that once we actually get to the demo portion as well. So you'll be able to see what you see when you do like a Terraform plan.
Gotcha. Thank you.
Yep. Okay. But coming back to the demo portion, so what we're going to be doing in the demo is we're going to be spinning up this repo that I have. Let me drop it in the chat as well as the YouTube chat. And so what we're going to be doing is we are going to create a new database in my Astra account. We're going to create a new key space. So when you create a new database via Terraform, or just Astra in general, you are already like part of the create database process. You create a key space by default in the creation process. So we're going to create a key space by default when we create the new database, but then we're going to use the create key space aspect of it to create another key space in that same database, the newly created one. And then we're also going to download a dependency graph to show you how to do that. I've already done some steps for you. We'll talk about that once we get to the actual code portion. We'll destroy the newly created key space. At least we'll try to. I did notice that it may be a little buggy. It might be something that might still need to get fixed. But when I try to do a Terraform destroy on the on that specific key space, like the newly created one that we'll create, it doesn't actually, so it'll say it got destroyed within Terraform, but it doesn't actually get destroyed via like Astra itself. So if I refresh the UI, it won't actually like say, it'll still be there, and then when I go into CQLSH, it'll still be there as well. So there might be a bug with the destroying aspect for key spaces, but destroying databases works fine. So with that, I will go ahead and spin this up in Gitpod, and while that's happening, let's see, just make sure it logs in. Okay, cool. So what I've done for you ahead of time is I've already done some commands to install Terraform. So all you need to do is one click, open this in Gitpod. So when it loads, it'll install HashiCorp tap from Brew, which we can use in Gitpod, which is nice. And then also Terraform itself. And then we're also going to install GraphViz. We'll need GraphViz to download the dependency graph. And then we'll also create just a clean file for the Astra TF for the Terraform file. So going through the repo, we'll just need to say yes here just to make sure we can install GraphViz. But while we do that, let's go ahead and clean this up a bit. And then Astra TF is created. And then we'll go ahead and open this up. And what we're going to do here is we are going to copy in the first aspects of the code, and we'll go through what this is doing. So with Terraform, we're saying required providers. So we're going to say Astra, source DataStax Astra. So when you're connecting to, or when you're trying to use the provider, if you go to the Terraform registry and you click on this use provider, it has how to use this provider. So if there's any changes in the aspects of how to connect to Astra or initialize it, you can do this here. Let's go back here. And so another thing we're doing, as mentioned previously, we'll need a token. They do mention that you can do this in another way by using like an ENB token, or using your token, setting it to the environment and using that as a variable. But we're just going to be using this for now. And what this is going to do is, because it does not read the Astra API token from your environment, it's going to prompt you for it. And you can do that just with the copy and paste. And so what this first thing is going to do, and we'll go ahead and spin this up because for my testing, this takes about a minute or two to create the new resource. In this case, it's going to be an Astra database. And we're going to call it Terraform. The default key space that we're going to create with it is going to be called test. The cloud provider is going to be on GCP, and then the region is going to be US East 1. There are additional things we can do, and we can take a look at that in a second. But first, what I'm going to do is go ahead and do a Terraform init. And so looking at the Terraform init, as Rahul mentioned, it like installed the DataStax Astra Provider, and it has the key, etc. And our Terraform project's now initialized. And so what we're going to do here is we're going to do a Terraform plan, right? So when we do a Terraform plan, it's going to ask us for our token. And actually what I'm going to do just to make this faster for us is I'm going to, sorry, it's copied on my second screen. Just going to copy this, and I'm just going to hard code this for now, just so that it doesn't keep prompting me. I realize now the next step I can do to improve this is to add it to my setup sh, where it'll prompt you for the token, and it'll save it to the environment, and that way you can just make this even faster, as an example. But coming back here, we'll do a Terraform plan. Oh, let me see, did it not? Comment that out. Okay, so here is what the Terraform plan is showing us. So what's going to happen is Terraform is going to create a new resource, an Astra database, and it's going to create it with these parameters. So some of these are what we're giving it, and some of these are going to happen after the apply has been run, right? So what we're going to do is we're going to go ahead and run Terraform apply, and we'll see the similar thing. And then we'll also need to confirm, right? So that's something nice to have, or it asks you to confirm this is what you want to do. And so in our plan, we see that there's 1 to add, 0 to change, 0 to destroy. So it keeps track of what's happening in this state file. So if we'll go ahead and hit yes, we'll see that it's creating. But while that's happening, we'll take a look at the state file real quick that was generated. Oh, I guess it'll actually update once it's it'll update once it's complete. But while this is happening, we can go to our Astra instance. Sorry, I was timed out and logged out, but coming back here, we now see that our Terraform database is pending, but it's being created, right? With a couple lines of code, we were able to quickly create a new Astra database without actually having to go to the UI and manually do it, pick our region. So if you know stuff ahead of time, you can do this very easily. So while this is happening, if we go back to Astra TF, again, for my testing, this took about like a minute and a half to 2 minutes. We can take a look at the documentation that they have here, but then we can also look at the source code. So in the source code, they have a couple things here. They have Terraform plan, apply, and Terraform show. They have some examples if you go into the examples folder. So they have some examples for the data sources provider. These are the same ones that show up on the registry examples. So if we click on resource database, this is what we just did, right? So we created a new resource with the name Terraform, key space of test, I think, and then we defined our cloud provider and then the region it will go in. And then there's also some optional things we can have. And then what we'll use next is this create key space. And what we'll be doing here is instead of providing manually a hard-coded database ID, we're actually going to be using like a Terraform HCL method to get the ID of the second deployed database that we have and just do that, right? So if we go back to Astra, we now see our Terraform database is now active, right? So it's on GCP and it's in US East 1 as we wanted it. So coming back to the repo, what we are going to now do is we are now going to get back the list of databases. Now we have 2, right? So if we go ahead and paste this in, so what we're doing here is we're using the data aspect and we're saying the Astra databases, get the ones with the status active now that they're both active. Where to go? Code, here it is. And then we're going to output the existing DBs. And then for each DB, the value of the output is going to be like a tuple of 2 strings. The first string is going to be the ID of my first database, and then the second is going to be the ID of the second database, the one we just created, the Terraform database. We can change DB ID to DB name, so that way you can actually see it that way, or you can change what this tuple will look like. But while we do that, or before we do that, we can also take a look at the Terraform state as mentioned. So here we see that in our resources, the state's managed. It has our Terraform test, the one that we created, and it currently hasn't picked up any other data because this is the only thing we've done with the Terraform file. So now if we go into here, let's just make sure this is saved, and we do a Terraform plan. What's going to happen is there's going to be a change where, as mentioned, it's going to output a tuple with the IDs of the databases, right? Because I have currently 2 databases, one called Databricks and then this newly created one called Terraform. So what we're going to do here is we're going to go ahead and do a Terraform apply and then confirm. And then after doing this, if we actually go into our Terraform state, there will be more stuff, right? So we now have this output section, which has the values of the first database ID and the second database ID, the type, and then in resources, again, it actually picked up our second database. So it picked up our first existing database, like our Databricks one here, and it also is keeping track of our Terraform one. So now if we move on to the next section, which will be to create a key space in the newly formed Terraform database. So what we're going to be doing here is we're going to be using a resource, Astra key space, and then we're just going to call it example. So looking back here, currently we only have test in our Terraform database. And if we go into back to the code, in their example, as mentioned, right, in the same exact thing, they're using a hard-coded ID value, right? Instead, what we're going to do is we're going to pull from the data that we got back here, we're going to pull from the results number 1, because 0 is going to be our Databricks database, 1's going to be our Terraform database. So when we go ahead and hit Terraform plan, we'll see that it's going to be a create, and then there's going to be a asterisk key space will be created. It's going to take the example name we gave it, and then it also picked up the database ID that we got back from above, right? So what we're going to do is now run Terraform apply. Nope, Terraform apply. And we'll go ahead and hit yes. And now if we go back to Astra, we do this a quick refresh. And we now see in our Terraform database, we now have the example key space that we just created. So it's very simple. You don't have to go into CQLSH. You don't have to manually create new infrastructure. You can do it all via Terraform. So doing this, we can just confirm within CQLSH as well. If we just do a describe key spaces, we see our example, right? So now if we go back to the demo, what we're now going to do is create a dependency graph. So as mentioned in the setup that gets run when this Git pod gets deployed, we are going to automatically download graph viz. When I had tried running this command, dot was not recognized. And so I found it, I installed it, and then I added it so it would be automated upon install or deployment of the Git pod container. So what we're going to do here is run a command that generates an SVG file called graph.svg. I'm going to go ahead and download this to my local and then open it up. So here, as we can see, a dependency graph of our current Astra TF Terraform file. So we see a couple outputs here, but we're also seeing the root provider, this registry Terraform Astra. Obviously, we're only using one provider, but if we have multiple providers, multiple infrastructure components, this graph would actually be much more distributed. And you'll be able to see a lot more and have it visually in a good spot. There is a comment in the YouTube chat from Rahul. One thing to note is that given different var files, TF vars, you can have the variables for different environments to use the same core Terraform for different sets of databases, Astra orgs, etc. So that's a good thing to note. Especially if you're working with an actual production environment. Let's go back to the code here. So what we're going to do here is, before running a Terraform destroy, what I had wanted to test and what I was testing while making this demo was that Terraform destroy key space. I was running into some issues as mentioned during the deck portion, where if we destroyed only the key space rather than the whole database, it didn't actually pick it up, even though Terraform confirmed, at least within Terraform itself, saying the resource has been destroyed. So what we're going to do first is we're going to run a Terraform plan flag destroy. So what we're doing here is we're saying Terraform plan, but plan it, show us what the plan would look like if we're doing a destroy. So when you do a Terraform destroy, it's actually Terraform apply flag destroy, but it's shorthand for doing the destroy aspect. So in doing this, let me go ahead and max this out, since what we're going to be doing here is it's picking up, it's going to be a destroy. It's going to destroy the database that we have, and then it'll also destroy the key space, and then destroy any outputs. Obviously, that's in the file. But in doing so, when I was doing testing, so if I do a Terraform destroy target. And so with target, we can target specifically specific resources that we want to destroy. So if I do, I have it copied down here. Let me paste this in. That'll be easier. Essentially what we're doing here is we're saying Terraform destroy target, so only destroy a targeted item or resource for us in this case, and this is the key space that we created. So what Terraform is picking up is we're going to destroy the newly created key space, the example key space, from the database ID that we provided it. And so we'll go ahead and hit yes. And so we see there's a warning that the applied changes may be incomplete. So maybe there's a possibility that the Terraform target is the issue, that is the buffer between running the actual destroy on the specific key space. But going into Astra here, if I refresh, the example key space still exists. And if I go into connect or SQL console and do another describe key spaces, we see that the example key space still exists. So maybe that's something either I'm doing incorrectly or the target doesn't work well or play well with destroying key spaces, but that's just something to note. Potentially, it might be something that's being fixed right now. I'm just not aware of it, but potentially there might be an issue if you want to destroy specifically key spaces and not the whole database. But coming back to the end portion of the demo now is we're going to destroy everything. So in this, we're going to destroy the whole Terraform database and everything we've done so far. So we're just going to run a Terraform destroy. And so again, as mentioned, it's going to destroy the database. The key space doesn't actually show up here because technically we already destroyed it via the Terraform target destroy. So we're going to go ahead and hit confirm yes, and we'll see a destroying. And like when it was spinning it up, it's going to happen. It's going to show us progress. But if we go ahead and refresh Astra, we'll see that this is now a red, and it's now indicating that it's being terminated. So it's actually picked up our Terraform destroy, and it's actually managing, hey, we don't need this database anymore. You can go ahead and destroy it. And this doesn't take that long, like the deploy process. So this is super fast. Astra's actually, like in general, is pretty fast in terms of spinning up databases compared to other managed things I've tried. So like when I spun up like Avon or Terraform or InstaCluster, those are a little bit slower, but still in terms fast. Skillet Cloud takes a little bit longer in terms to spin up the cluster as compared to Astra. But yeah, that kind of wraps up what I have here. While this is just destroying in the background, we can open up the floor to any questions or comments, or if anyone's ever used this provider specifically, if they've noticed anything that they've worked with before, or any nuances that they would like to inform the community about, feel free. And now our resource is destroyed. So if we just go back to Astra, give this a quick refresh, and now we're only remaining with the original database I already had. Yeah, that wraps up the demo portion. And open up the floor again, back to questions. Or comments, feel free. Oh, sorry, my chat got closed. Okay, there we go.
Do you have like a preference on how you like to manage your Astra instances? Like, is this more of like a use case thing, or are there alternatives to Terraform that you've explored and tried using at all?
Not specifically. We work with Terraform here at Anant, Terraform Ansible, to help do the infrastructure and then software installations. But Terraform Terraform is, I think, pretty much becoming a standard in terms of infrastructure management, just because how easy it's used. But I don't know, potentially there might be other infrastructure tools, but I think the main one out there and in use and community driven as well, probably Terraform. There is a question, or sorry, any follow-up questions to that? Okay, there is a
No,
question
thank you.
chat from YouTube. YouTube, do you know if the provider is updated often, either from the Terraform registry or the GitHub repo for it? Yep. So the most recent release for the provider was 10 days ago. Yep. But development on the provider itself, I looked through the commit history. It started in April of 2021. Looks like the first commit was, or April 12th, 2021. But from what I'm seeing here, at least in the commit history, it is being worked on. So the last commit and release 10 days ago, but looks like it happens on a weekly basis, it looks like. Um, but there are commits monthly. So in terms of is it being updated often, if you consider monthly often, yes, it is. Um, and the version 2.03 in the registry matches up with the release version here. So I think as long as they continually update this in a monthly fashion, we should see updates in the registry itself. If that answers your question, Rahul. Yep, there's also a comment in the chat from Jeff Donito. We, the DataStax team, work very frequently on the provider, so that also answers the question there. So maybe a question for you, Jeff, that I had, where I noticed that the destroy for the key space wasn't it 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 marked it as destroyed with Terraform, but it didn't actually destroy it within Astra itself. Is that something you guys are aware of, or something that you're already working on? Okay. Jeff, there's also another comment from Jeff in the chat, responding to questions as they come into the repo and looking at issues and releasing patches to address incoming stuff. So looking at the code itself, there are some issues here. So there's some recent issues, also a couple older ones, but only going back to September. So yeah, it looks like it's being updated often and being addressed. Potentially, I can create an issue regarding the destroy key space. So the follow up on YouTube from Jeff. Sorry about this. The YouTube's actually a couple seconds behind what's happening in Zoom, but the Jeff has responded, yeah. So that's actually a limitation of the DevOps API that the provider interacts with. Okay, so cool. So I wasn't I wasn't pulling out hairs when I was running into the destroy key space issue. Cool, great. I think that's good to have. But yeah, no, this is really cool to be able to manage your Astra instance or instances via Terraform and do infrastructure as code. Is super cool, super easy. Like this demo, like learning it and then doing it, putting it together, resolving issues. Super simple. Documentation's good. And so yeah, definitely if you're interested in Astra and Terraform, this is definitely a cool thing you should look into and get your hands dirty with. Right. If there are no more questions, I'll go ahead and wrap this up. Thank you everyone for joining us here for Cassandra Lunch. Again, if you're watching this on YouTube right now, don't forget to subscribe and like, and subscribe to keep up to date with all the Cassandra Lunch videos, but then also our sister lunches, Data Engineers Lunch. You can find out more of our upcoming events on Eventbrite Meetup, our events page, anant.us/events. Again, to put it out there if you're not familiar with it, I accidentally closed it out, but DataStax has their build-a-thon that starts on February 21st, and Skilla Summit is currently ongoing. Today is the second day, so be sure to look out or attend those. And we will see you guys next week, same place, same time. Take care.